Arden Labs, specializing in high-performance software consulting, training, staffing, and development. Module 10 Channels. You are now watching Lesson 10.9, Cancellation Pattern.
Okay, the last pattern we're going to look at is a cancellation pattern. And maybe this is the most important pattern that we have in Go, especially if you're building web services and long-running servers that perform tasks, because no web request or task can take forever. You got at some point decide to quit and send back a result to that client. And this is how we do it with cancellation. If you're not dealing with timeouts, you're going to cause problems in your server. They will implode because you got Go routines running for a long time and you got new work constantly coming in. So one of the most important things we can do in a server is identify what is the maximum amount of time we're going to take to handle any request and set timeouts on things like database calls, web calls, external calls, things like that. You may not know what these timeouts are while you're developing the code, but you want to lay these timeouts in, and eventually, as you start doing some load testing, figure out what these numbers are. So cancellation is something that you have to do early on in the design and architecture of your software, even though if you might not know what those numbers are up front. So let's take a look at a classic cancellation pattern in Go, and we'll be using the context package to do it. So on line 257, we have a duration value that's being set, and it's going to be 150 milliseconds. So what we're going to say is we're going to perform some operation, and we're only going to wait 150 milliseconds for it to complete. So there we are using the context package, and we're using the with timeout function. Now what the with timeout function says is, pass me an existing context that's in play, tell me that the duration is, and I will send you a new context. If you notice, with timeout, really the context package uses value semantic mutation. We pass a context in, we get a context out. And a lot of the reason for that is because higher level calls should be telling lower level calls how long they want to wait, what they want to do, state changes. And a lot of this has to be kind of local to where you are on the call stack, and you don't want to affect things above the call stack. Everything is kind of localized. So what we're going to say is, since I don't have a context already, let's start with the background context. And the background context is basically an empty context. It's where we start. So we start with the background or empty context. We set a 150 millisecond duration, and we get a brand new context. Now, if you notice, we also get a cancel function. It's critically important that the cancel function gets called at least once. So there's a pattern here where when you call that with timeout function and get the cancel function, we immediately defer the cancel and guarantee that it gets called. Cancel can get called multiple times. That's not a problem. But if it doesn't get called at least once, you can leak memory in Go. So if you've got memory leaks, one of the first things I might look at is, are you using context? Are you forgetting to call cancel? So don't forget, cancel has to get called. Okay, we now have a context. We're ready to use it. I go ahead on line 261 and I create a buffered channel, but a buffered channel of just one. There it is. So we're going to be able to signal with string data, and we are taking some risk, right? Because there's going to be really no guarantee, at least no guarantee of one signal send. Okay, on line 263, what do? We launch that Go routine and we tell that Go routine to go do some work. I've highlighted line 263 just again to simulate the work that it's doing. And in this case, we have no idea how long that's going to take. I'm choosing a random number between 1 and 200, which means that this can happen longer than that 150 millisecond timeout that we're setting up. So again, we're only willing to wait 150 milliseconds for this work to get done. And that Go routine is off. Once the Go routine finishes the work, it will signal the result back over to us. Now, while that Go routine is off, executing work on line 264, we are in our select case. Again, there is no default here, so this is a blocking call. And there's two signals here that we're blocking on. We're hoping to receive the result from the Go routine that's eventually going to signal on line 265. That's our best case scenario. In other words, the work got done in under 150 milliseconds. But in case it doesn't, there we are also blocked on the signal for 272, on line 272. And we do that through the done call. So immediately when we call the done method, the clock starts running on that 150 millisecond duration. Now the clock is set and we're sitting here. Hopefully that go routine signals on line 265 within the 150 millisecond time frame. Because if it doesn't, then this case is going to signal first and we're going to move on. And that's how that cancellation works with context. Now I do want to show you a classic bug that a lot of developers produce with cancellation. And it comes from not setting the channel correctly. Imagine that I didn't use a buffered channel of 1. Imagine that I used an unbuffered channel. Remember what the unbuffered channel means. It means we now need a guarantee that a signal being sent has been received. It means the send and receiver have to come together, and then the receive happens before the send. Imagine right now I've put my unbuffered channel in. The go routine is off doing work. It's now been 150 milliseconds, and so this go routine over here signals on that case on line 272 and moves on. It moves on. But this go routine hasn't moved on yet. It's still busy on line 264 doing work. Then it comes into line 265. It wants to signal the result back. But guess what? There is no go routine there to receive it. We now have a unbuffered channel. We have the guarantee. That send cannot finish without the receive, and there's no receiver in sight. We now have a go routine leak. Very classic. So anytime we're doing cancellation, one of the first things that I'm going to look for is that the channel is being constructed as a buffered channel of 1. Because by doing that, we guarantee that if the go routine on the receive side walks away because of a timeout, the go routine on the send side can still complete and not leak. Classic cancellation patterns using the context package. This is how we're going to be doing it in Go. And probably out of all of the patterns we looked at today in this class, this is the one that you'll probably use most often because our web services, our long-running tasks must have timeouts, must have cancellations, and this is the pattern and how we do it.